Hello everyone, I'm Shusei Tomonaga from JPSAT. Our presentation today is about how an attacker spread infection in the network and some tips that may help such analyzing lateral movement, which we just published in a report recently. So first of all, let me introduce ourselves. My name is Shusei Tomonaga. I have been working at JPSAT Analysis Center for 5 years. My primary responsibility are to analyze malware and DFIR. We have been publishing analysis observation on our blogs. We also developed some tools. Which are useful for malware analysis. They are available on GitHub.
And my name is Keisuke Muda, and I work on the Internet Initiative Japan, or IIJ for short, and I'm an analyst at the Security Operations Center. And as a member of IIJ SOC, I'm primarily working on the analysis of logs sent from customers' networks and research and analysis of software vulnerabilities and enhancement of IIJ SOC service and the IIJ service infrastructure.
So before I get into main topics, I would like to talk about some issues in DFIR and APT incident. First, many hosts need to be investigated at the APT incident response, and attackers that has intruded into a network usually infect many other hosts and server, and as well, and spread infection within the network. For investigating such hosts, we obviously need logs. However, logs required for investigators are not always recorded. Therefore, it is often difficult to detect or investigate lateral movement. So, in this presentation, I will introduce our approach to those challenges. Through the analysis, we have found a limited set of tools are used in many different incidents for lateral movement. So if you know what log acquired with the tools, investigation process will be smoothly. This is today's presentation topics. We will talk about overview of APT incident and lateral movement, and typical tools used by attackers. Finally, I will introduce some techniques for tracking lateral movement. First, research of lateral movement. We examined the tools used by the attacker. For this research, we use a disk image of the CNC server and decoded malware connections. Forensic investigating disk image is APT10, APT17, Dragon OK, Blue Termite, and Tick. These campaigns target at Japanese organizations. This is an example of the list of the files in the Shih-Tzu server that Blue Termite was using. Malware named G-Status was managed by IIS and Access Database. So another example, malware named MDB was managed by PHP and SQLite database. And the executed command by the attacker was saved in the database. We examined the command executed by the attacker from the server of Shih-Tzu. Total command executed is 60,866. As a result of analyzing the corrected command, I found an interesting fact. We found that 84% of the command executed by the attacker are the Windows command. There are many control commands for malware, but the attacker tends to use Windows command. Attacker use not only attack tools, but also Windows command and legitimate tools. Why do attackers use Windows command and legitimate tools? Be- because they are not detected by antivirus software. Next, let me introduce the tools that attackers use for lateral movement. This slide introduces the flow of APT incident. An attacker who infected the host with malware collected information on the host. Next, they collect information of other hosts and the server within the network, and they spread the infection to other hosts. They will send confidential information using cloud service and so on. Last, they delete logs and created files. Lateral movement has 4 steps: initial investigation, internal recon, spectator infection, and delete evidence. After this slide, I will describe what kind of tools are used in the 4 steps of lateral movement. First step is initial investigation. The most used command is task list. If the attacker is not interested in the infected host or realize the malware running in a sandbox, they will escape soon. So this table summarizes the Windows command executed by the attacker. Attacker use task list, var is version, ipconfig, system info, and so on. Second step is internal recon. The most used command is dir. The attacker look around confidential data stored in the infected host. For searching the network, net command is used. An attacker investigate confidential data using dir and type command, and to search domain network, net command options are used. Ping and echo command are also often executed. Net command is a powerful tool that many attackers use. Net command can investigate various information of domain network. We found that attackers use commands such as ping at this stage. Why ping command is often executed? The reason for this is simple. They use ping command to search the local network. As an example, another common command used by attacker is echo. Why echo command is executed? Because they use echo command to create script files. They are often created with the echo command rather than downloading a script file. This is a continuation of the details. dump.el and log parser are not installed by default Windows. These commands analyze the event log created by Microsoft. Attackers are collecting a list of users who log on using these commands. Third step is spectator of infection. The most used command is AT command. Attackers use AT command to execute the command on the remote host. AT command is not supported on Windows 10 and Windows 8. If at command cannot be used at the environment, we found that SCH tasks is used. WMRC is another method of remote command execution. Attacker use move, copy, and regi command to install malware on the host. Other example of installing malware, by using mofconf command, attacker can register WMI command to repository so that a command can be executed periodically. Fourth step is delete evidence. The most used command is delete command. In a few cases, they use wbt-util to delete the event logs. They also use delete, task kill, klist, and wbt-util command. In addition to delete event logs, wbt-util can search them. This example is searching logon event ID. Other example of delete evidence, they remove ticket or pass ticket. Recently, pass hash is not used for malicious logon. They tend to use pass ticket such as golden ticket and silver ticket instead. An attacker can delete these tickets by using klist command. So this is an example of the lateral movement steps executed by tick attackers. The first initial investigation is who am I command, then use Mimikatz to create golden ticket. Internal recon use the ping and dir command. So they executed the file to remote host with copy and at command, and finally delete the files.
Okay, from this point, I'm going to talk about how the attacks can be traced. And in terms of tracing attacks, by default on Windows, some logs are taken on the Windows logs. For example, if it's a client OS, then the logs on the successful and failed logons, successful logoffs, and successful policy modifications are recorded. And if it's in server OS, then successful authentication is also recorded. But that's pretty much about it. And we can see some of the logon histories from the default Windows logs, but there may not be enough record for proving other activities, such as execution history and access histories. And we think that's a problem. So what we did is we've analyzed them. So we've taken 49 different tools that were frequently used in attack behaviors, and we've actually run them on the virtual networks and see what logs can be collected. And out of these 49 tools, about 1/3 of them were legitimate Windows tools. So that indicates that these tools would not be detected by anti-malware software. And from our research, we've concluded that in most cases, we needed to do some additional tweaks to obtain enough records for tracing the tools. And our research is published on the JP-CC website, and it started in Japanese, and it's also in English. And we first published this on June 2017, this year, and we've updated this on this Tuesday, and it's on the website. So what's published here is we have the tools listed on the left side of the page, and on the right side of the page, we corrected the logs that are produced from the tools. And what logs are on the documents are the Windows event logs, and that's for both default and additional logs, and registry and cache for performance improvements, and file system activities, and file and folder access histories, and network traffics. And among those elements, we came up that the event logs was most useful among the entities. And when I say about event logs in this presentation, I'm talking about the audit policy and SysMon and application logs. But there are also some other useful information, such as USN journals and packet captures, and I'll talk about these also in this presentation. So from this point, I'll talk about one of the analysis tools used by attackers and see what we've done to publish the report and what can be found out from the logs. And the example I'm going to pick up here is the ps-exec. And probably most of you know what ps-exec is, but it's a legitimate tool and part of Microsoft sysinternals. And what it does is it executes a specified program on remote host. And it is legitimate too, but it is sometimes used in malicious ways. So we pick up this as an example. So if ps-exec was executed, and see what can be founded on the default Windows. And before getting into details, I'm going to talk about the terminology. When I say target host here, target host is where the remote command was executed. And when I say about the source host, that's about where the ps-exec command was executed. And in terms of the logs recorded on default Windows, on the target host, the installation and execution and termination of the ps-exe SVC, which is a service for handling the ps-exec on the target host, remains in records. And I'm going to show the example in the next page. And for on the source host, there are some logs that remains. For example, if prefetch is enabled on the host, the prefetch file remains in the prefetch folder under the Windows directory. But if it's a Windows server or the Windows clients under certain conditions, such as virtual machines, then prefetch is disabled by default, so it doesn't help. And another example is if ps-exec was used on the source node for the first time, it pops up a license agreement message and asks you, do you accept the license agreement? And if you say yes, then registry will be modified and say you've agreed to the license agreement. But again, if ps-exec was used before the attack, then registry would not be modified, so it doesn't help either. Okay, and this is an example of the ps-exe SVC executed on the target host. And from this log, you can say the ps-exe SVC service enters a running state, but it doesn't really tell what specifically happened. So we need to figure out and see what has happened. We need to know more about the incident to figure out what has happened within the attack. So what we do is we start off with the process auditings. So it's on Windows by default, and enabling the audit records gives more details about the program executions. And if I enable the process audits and take the logs on the Windows, and that's Windows event logs on event 4688, what you can see on the right hand of the screen is it says ps-exe svc.exe was executed, and the token elevation type was type 1. Okay? And the other thing you can find out is cmd.exe, that's a command prompt, was executed, and its parent process was the ps-exe svc. Okay? But, it says command prompt was executed, but that's about it, and still not sure about what has happened. So we need more information about what has happened. So we need to know about the command lines. Now, there are two options for recording command lines on Windows, And one is to install sysmon from sysinternals, and other is to enable the command line process auditing. And there are many other ways for doing this. And in our research, we came up with sysmon it would be helpful, and I think pretty much everyone knows about what sysmon is because it was on the writing talk yesterday. And it keeps track of exe file hashes, and it can be used for obtaining other artifacts, which I'm going to describe later. And it can be installed on both the server and client windows. So we came up with the system would be more helpful. So it's about the process auditing, and the next comes to the registry. And registry events can be recorded on both audit and sysmon logs also. And from our research, we came up that the audit logs and sysmon both gives the sufficient information for proving what has happened. And one thing that's important is in both audits and sysmon, it requires the configuration for logging them is necessary. And for the file audits, access to the file shares and access to the file systems can be tracked by using the audit logs. And if we are just talking about the file creation, then it can be logged with sysmon too. And we think that with sysmon logs is easier to read for humans. But for logging the file creation sysmon, you need to do additional configurations, and it doesn't track the file modification and deletion, at least at the version we've tested. And another example that can be logged with both sysmon and audits is the network connection. And again, both have similar contents, but the sysmon is easier to read. So I've talked about audit logs and sysmon logs, and which one should we use? Well, actually use both of them. And there are both pros and cons for using the audit logs and sysmon logs. And the pros for using the audit is it's available on Windows by default. And some information are logged on audit logs only. That's the pros for using the audit logs. But cons for using the audit logs would be some logs are confusing, and you have to be familiar with the ideas of the handles and the bindings in some of the logs. And that's sometimes a confusing for, especially if you're seeing the logs for the very first time. And another cons for using the audit logs is it has fewer details on sysmon in some cases. And so comes for pros on sysmon, it's easier to read relatively, and it has some more details such as file hashes and command lines. But for cons for using sysmon is you need to install software, and sometimes you need to make additional configuration, and you need to make an XML file for doing this, and that sounds complicated. Okay. Now I've talked about event logs, and there are some other useful information I'm going to show you here. And one is the USN journals, and one is the packet captures. So for the USN journals, assuming we are talking about Windows, we are using the NTFS file system. And when files are created on an NTFS file system, then USN journal will be recorded. So it says file create and file extend and file delete, and those are recorded on the USN journals. So audit logs can be useful for tracking creation and deletion, but also USN journal could be helpful for tracking the file creation and deletion. And another thing I'm pick up here is the packet captures. And PSExec uses SMB2, which many Windows programs do. And it can be tracked from the packet captures. So if you see the packet capture on the PSExec, it says create request file psexcsvc.exe. That means to copy the psexcsvc.exe to the target host from the source host. And another thing that's pointable is create request file svcctl. That's to bring up the psexcsvc service on the target host. And one other thing you can find out from here is you can change the file name of psexec.exe on the source host, but even if the name is modified, the file name copied here, psexe.spc.exe, remains this way. So that's one thing you can figure out from the packet captures. And another thing you can find out is if you're running the psexec and the std in, std out, and std errors, that's the command, that's the result of running the commands. So it's also requested via the SMV2. And this isn't just an example in this psexec in this case, but if the program uses the SMV2, then oftentimes the operations can be monitored through the packet captures. So up to here, I've talked about Windows event logs and user journals and the packet captures. So why do we trace from the logs? Well, it gives the details of attacks and the details of attacks could be illustrated from the logs. So if an attack created temporary files or registry values and then removed them, then it becomes hard to figure out the contents for doing the forensics. If you know what files were created, then you might have an idea of knowing about what has happened during the attack. And another thing is, if the command line is not recorded at all, it becomes hard to figure out what was done during the attack. So the logs would be useful. But there are also some challenges to this, because, well, first, logs sometimes may not be enough, and you may need to have additional logs for obtaining more details. And those examples include the operation logs of client computers and network activity logs, and etc. The second point in challenges is it is necessary to tune up log sizes appropriately because the default size for the Windows is 20 megabytes on the event logs, and all the logs might get overwritten once they get too large. So you need to tune up the logs appropriately. And the third thing is the logs could be purged during the attack. And the first part of the presentation, we came up with the WEBT util that can delete the Windows event logs. So it may be necessary to keep live logs to a safe location using protocols such as the syslog or the event subscriptions of Windows servers. So those are challenges for this. And to conclude our talks, the points we want to point out here are 3 points. One is typically limited set of tools and commands used for lateral movements. And 2, many attack tools can be detected with audit policy and system. And lastly, our report would be helpful if you're investigating ABT incidents. And that's it from us, and thank you for listening.
Thanks a lot for a great talk. Any questions? No? Okay. Thanks a lot.
Thank you.